Good morning, everyone, and welcome to the final day of the first SCCEE International Virtual Conference on Building the Future, Innovations and Challenges in Sustainable Civil Engineering. Yesterday was truly exceptional as we had the privilege of engaging with many brilliant researchers from various domains within civil engineering. I'm confident that today also will be equally enriching with presentations showcasing high caliber research. We will begin now with the last session chaired by Dr. Salam Armoush and Professor Muayyad Subh. Dr. Armoush is a civil engineer specializing in structural engineering, construction materials, and smart concrete and structures in civil and environmental engineering. He currently serves as a lecturer in the Civil Engineering Department at the College of Engineering, University of Anbar. He has numerous publications on topics such as smart concrete, self-sensing concrete, self-healing concrete, and gamma shielding. Dr. Armoush will chair the first 3 lectures in this session. Following him, Professor Muayyad Subh will chair the remaining lectures. Professor Subh is the head of the Structural Engineering Department at the Faculty of Civil Engineering, Damascus University. He's an expert in steel structures and has served as a director in various companies in Spain, Germany, Saudi Arabia, and Syria. Please join me in welcoming Dr. Armoush and Professor Subh to lead our final session. Dr. Armoush?
Yes.
The floor is yours.
Can you hear me, Mr. Adi? Dr. Adi, can you hear me?
Yes, I can hear you.
Okay. Thank you very much. Thank you very much, Dr. Adi, and welcome all the connectors and presenters in this, I think it's the last session in the first SCCEE International Virtual Conference. You are welcomed all. Please note, every presenter have 10 minutes for presenting his presentation, and we have 10 minutes for the discussion for every research. Dear all, you are welcome to consume that time. We will start direct with the first search titled
Dr. Salam, just a point that the first participant is not here yet, so you may start with the second one and we can get back to him later on.
Okay, no problem. Since the first one not here, so we can start with the second one and then we will continue to the first and the others. So we will start with a research titled Alternatives to Mitigate the Inferior Mechanical Properties of Concrete Containing Cross-Linked Polyethylene Plastic Waste with Dr. Dana Nasser from the University of Balamand, Lebanon. So, Dr. Dana? Dr. Dana here?
They will play the video now. She recorded the presentation since she had a special circumstances and she wasn't able to attend here today. So they're gonna play the video for her presentation.
Okay, no problem. So we can start now.
Mr. Fawaz, we cannot hear presentation.
Dr. Ali?
Yes, Dr. Salam.
Can you start again the video?
Yes.
Good morning. This is Dr. Dana Nasser. I am an assistant professor and the chairperson of the Civil and Environmental Engineering Department at the University of Balamand, Lebanon. My presentation today is about a work entitled Alternatives to Mitigate the Inferior Structural Properties of Concrete Containing Cross-Linked Polyethylene Plastic Wastes. This work is done in collaboration with Dr. Ali Jahami, Dr. Firas Barraj, and Professor Joseph Asad. It should be mentioned that environmental activists have turned their focus toward the imperative need of recycling post-consumer plastic wastes. Plastics are normally produced using thermoplastic or thermosetting polymers. The recycling of thermoplastic type derivatives, including melting, processing, and remolding, is very well documented in the literature, which is not the case for thermosetting type derivatives. Thermosetting type derivatives cannot be recycled due to their infusible and insoluble properties in the melt state. Therefore, this work discusses the possibility of recycling post-consumer plastic wastes, mainly the thermosetting type derivatives like cross-linked polyethylene XPE, which cannot be recycled in a conventional way given their infusible and insoluble properties. This work is part of a comprehensive research study undertaken to assess the feasibility of concrete mixtures containing thermosetting type derivative plastic, mainly XPE. The current disposal methods used, mainly like landfilling or incineration, cause huge environmental risks. Thus, this study explores the possibility of incorporating 3% XPE plastic waste by volume into concrete mixtures as an environmental friendly disposal method. Previous research studies showed that adding XPE to concrete can weaken the concrete mechanical properties due to their relatively reduced density, weak characteristic strength when compared to natural aggregates, and poor adhesion bond with the cement paste. Three main alternatives are assessed in this work to restore the concrete mechanical and structural properties after the incorporation of 3% XPE plastic waste. One, reducing the water to cement ratio from 0.55 to 0.46. Two, the addition of 1% steel fiber. And three, an addition of 15% styrene butadiene rubber SBR latex as a mixing water replacement. Reinforced concrete beams without stirrups are tested for shear strength to study the possibility of using XPE in concrete construction, which represent an efficient disposal method of XPE plastic waste without harming the land and the marine environment. Let's talk now about the experimental program. Mainly, let's start with the materials. So ASTM C150 Type 1 Portland cement is used as a primary bonding material along with natural siliceous sand and crushed limestone coarse aggregates, high-range water reducer HRWR based on naphthalene sulfonate to improve the workability of the concrete mix, steel fibers microfilaments having 13 millimeters length and 0.18 millimeter diameters, a commercially available SBR, commonly used as a bonding agent, the XPE material that were obtained by shredding high-voltage electric cable plastic waste into pieces measuring 2 to 12 millimeters in size, as you can see in the picture in this slide. Moving now to the mixed proportions. 5 concrete mixtures are tested in this work. One, the control mix with no XPE, which contained 325 kilogram per meter cube cement, a water to cement ratio of 0.55, and a fine to total aggregate ratio of 0.45. The second mix incorporates XPE shreds at 3% rate by total concrete volume. It should be noted that fine and coarse aggregates are adjusted accordingly to maintain a fixed aggregate ratio of 0.45. The third mix is with 3% XPE plastic waste and reduced water to cement ratio from 0.55 to 0.46. 4, mix with 3% XPE and 1% steel fiber by volume. And the final mix consists of 3% XPE and 15% SBR as a mixing water replacement. Let's talk now about the testing methods. So our purpose was to determine the hardening density, the compressive strength, the splitting tensile strength, the modulus of elasticity, flexural strength, and shear strength. The mold that are used for testing reinforced concrete shear strength have the following measures: 150 by 150 millimeter square cross-section and 780 millimeter length. The 28-day simply supported beams were subjected to 2-point symmetrical loading. The vertical load was distributed on 2 points acting on the beam surface through rigid steel supports. And the load was applied gradually at a rate of 0.2 kilonewton per second. Finally, the midspan deflection was recorded using an LVDT or linear variable differential transformer placed on the tension side as shown on the figure in this slide. Let's talk now about the test results and discussions, and let's start with the plain concrete properties. The HRWR demand that was used to achieve a fixed slump of 200 plus or minus 15 millimeters, the hardened density, and the mechanical properties like F prime C, FT, FR, and modulus of elasticity of tested mixtures are summarized in the shown table here. It is clear that the HRWR dosage slightly decreased from 2.65% for the control mix to 2.5% with XPE addition, and this value remarkably increased to 3.7% when the water to cement ratio was reduced from 0.55 to 0.46. This can be related to reduced mixing water and increased internal friction within the aggregate skeleton. The density of the hardened concrete decreased from 2,315 kilogram per meter cube for the control mix to 2,225 kilogram per meter cube with 3% XPE additions. The drop in the mechanical properties due to XPE additions is very clear in this table. This drop was recovered when the water to cement ratio was reduced from 0.55 to 0.46. So for example, if we look at mix 3 containing 3% XPE and a reduced water to cement ratio to 0.46, we can notice that F prime C, for example, reached 30.8 megapascal and FR reached 5.6 megapascal. So we can conclude that reducing water to cement ratio is an appropriate alternative to refine the matrix porosity and ensure strength development. Alternatively, when steel fiber and SBR were incorporated, we can note that only the tensile-related properties were recovered. For example, FR reached 6.42 megapascal when 1% steel fiber was added, and FR reached 6.08 megapascal when 15% SBR was used. For fibers, this can be due to a bridging effect that delays the formation and the propagation of cracks during tensile loading, which leads to improved flexural properties. For SBR, these polymeric lattices are efficient to improve the adhesive bonding within the aggregate skeleton. The values that we have seen in the table are plotted in this figure that show the mechanical properties, mainly the compressive strength and modulus of elasticity in the bottom figure, and FT or splitting tensile strength and flexural strength in the above figure for the different tested concrete mixes. It is very clear that the mechanical properties dropped with XPE additions due to their weak strength and lightweight characteristics if compared to natural aggregates. This drop in mechanical properties due to XPE additions was recovered as previously seen when the water to cement ratio dropped from 0.55 to 0.46. And for the last two mixes, as previously mentioned, the values of FR were recovered with the incorporation of steel fiber and SBR. Let's move now to the shear strength of reinforced concrete beams. As shown in the figure presented in this slide, all reinforced concrete beams displayed similar load versus midspan deflection curves. So we can see that the control beam failed at a value of Pmax or ultimate load of 57.94 kilonewton and a deflection delta max of 2.77 millimeter as shown in the table of the next slide. On the other hand, when 3% XPE was added, we can see that this addition of XPE greatly reduced the shear strength properties, resulting in a drop in Pmax that reached 49.22 kilonewton and a drop in the corresponding delta max to 1.58 millimeters. So when XPE was added, we can see that this drop may be due to many reasons. One reason may be the reduced concrete density and strength, which both can weaken the beam's resistance to applied loads. Another reason may be the poor interfacial adhesion between XPE particles and the cement matrix, which results in decreased shear transfer along the diagonal crack surface and lead to sudden beam failure. So in addition to the values of Pmax representing the maximum load capacity and delta max representing the corresponding maximum deflection, the table in this slide summarizes the values for the tested reinforced concrete beams corresponding to V crack, which represent the first diagonal cracking load, and PDC or post-diagonal cracking index that is used to quantify the maximum beam resistance after the formation of the first diagonal crack. So let's discuss these results together. So from the previous figure representing the load versus midspan deflection plot, we can conclude that the performance of reinforced concrete beams with the addition of 3% XPE was fully restored or even surpassed the performance of the control beam when the water to cement ratio was reduced from 0.55 to 0.46. The corresponding values of V crack, Pmax, and delta max for the mix, including 3% XPE and 0.46 water to cement ratio, are the following: 56 kilonewton for V crack, 65.27 kilonewton for Pmax, and 2.23 millimeter for delta max. Thus, the disposal of 3% XPE plastic weight in concrete production can be achieved without negative effects on the structural properties, given that the mixing water is adjusted to restore the concrete strength. Alternatively, the steel fiber or SBR alternatives also proved to be efficient to restore the reinforced concrete beam's performance, but these remain slightly less performant than the water to cement ratio reduction alternative. For example, when 1% steel fiber was used in the concrete mix, the values of the shear strength properties reach V crack 44 kilonewton, Pmax 54.7 kilonewton, delta max 2.17 millimeters, and PDC index 19.6%. Whereas when 15% SBR was used, the values reached 46 kilonewton for V crack, which was equal to the value of V crack for the control mix, 58.29 kilonewton for Pmax that exceeded the value of Pmax for the control mix, delta max reached 2.49 millimeters, and PDC reached 21.08% and exceeded the value of PDC corresponding to the control mix. So for the case of concrete containing steel fibers, the improvement in performance can be due to the bridging effect that reduces the initiation of cracks during loading and promotes higher aggregate interlock along the cracks. Alternatively, for the case of concrete containing SBR, the improved performance can be due to the presence of polymers that enhance the bonding along the XPE particles and cement matrix surfaces. Additionally, the use of SBR improved the bond to embedded steel bars, which densify the interfaces along the longitudinal reinforcement. Finally, it was shown that the post-diagonal cracking index remarkably increased. It became pretty close to the control mix when steel fiber was used, and it even surpassed the value of PDC corresponding to the control mix when SBR was used in the mix. So we can say that these results indicate the efficiency of steel fibers and SBR in restoring the beam resistance after the formation of the first diagonal crack, despite the addition of 3% XPE plastic waste. So let's conclude this presentation with the following concluding remarks. This study is part of a comprehensive research work undertaken to assess the feasibility of incorporating XPE plastic waste in concrete mixtures as an environmentally friendly way of plastic waste disposal. The primary objective of this study is to explore different alternatives to restore the concrete mechanical and structural properties after the incorporation of XPE additives. Test results showed that the addition of 3% XPE by volume to concrete mixture caused a drop in the compression and tensile responses due to their weak strength and lightweight characteristics when compared to natural aggregates. One main alternative proposed in this work is the reduction of the water to cement ratio from 0.55 to 0.46 while adjusting the workability with additional superplasticizers. This alternative was found efficient to refine the matrix porosity and enhance the plane and structural properties of concrete containing XPE plastic wastes. Other two alternatives were also proposed in the study and were based on incorporating steel fibers and SBR respectively. The tensile-related properties were recovered with the addition of steel fiber and SBR due to improved bridging and bonding that can delay the formation and propagation of cracks. The shear strength of reinforced concrete beams containing XPE waste improved with the addition of steel fiber and SBR due to the enhanced aggregate interlock mechanism along the diagonal fractured surfaces. And as a final conclusion remark, we can state that such data suggest an efficient way of disposal of XPE plastic waste in the construction industry without harming the land and the marine environment. Thank you.
Just to make things clear, if you have any questions, kindly, I shared Dr. Dana's email, so maybe you can send it to her directly since she was the major author for this paper, for this work. Since she won't be able to be here also to answer the questions due to, as mentioned before, her special circumstances. Dr. Almoush, back to you. Dr. Hakim, do you have anything
No,
to say?
if there is any, we have some questions about this article, but if the author is not here, so we will discussion after.
Okay, Dr. Salam, back to you.
Thank you very much, Prof. Hakim. As Dr. Ali mentioned before that Dr. Dana is not here and she was not able to join us. So you can direct your questions directly to her email. Normally she used XPE plastics with a different ratio, or she mentioned that 3% of XP and she changed water cement ratio and she used SBR to control and to see the differences in mechanical properties comparing to the control specimen. So any questions you have, you can send it directly to her email. So I don't know if Prof. Tahani joined us.
He didn't attend yet, unfortunately, Dr. Salam. So we may continue with the next participant. I'm trying to reach him, Professor Hakim, but if you know his number, maybe you can call him. I sent him an email. Maybe we can proceed with the next participant, Dr. Salam.
Okay, we can move to the next participant. The research titled Assessing Routing and Fatigue Distress Uncertainly in Recycled Asphalt Pavements. The presenter will be Dr. Ali Atom. He is independent researcher from Lebanon. So, Dr. Ali, please, you can start.
Dr. Firas, we cannot hear you.
Okay, now. You can see the screen, Dr. Ali?
Yes, we can see.
Okay.
Okay, now it's okay from my side.
Okay. So I'm Dr. Firas Barraj. The work was done by Dr. Ali also, but I will be the one presenting this work. So our work is entitled Assessing Rotting and Fatigue Distress Uncertainty in Recycled Asphalt Pavement. This work was conducted by Firas Barraj, Ali Hatoum, Nabil Sam'an, Rawan Ramadan, and Dr. Adel Kurdi from the University of Balamand and Beirut Arab University. So here are the main highlights of the presentation. I will talk about the motivation behind this work, the problem statement, the objective targeted, the experimental program to characterize asphalt concrete material and field performance, the methodology used to assess the variability in asphalt mixes performance, leaving with some concluding remarks. So starting by the motivation, while the cost of raw material is always increasing and strict environmental regulations are imposed, pursuing sustainable development in the asphalt industry become a necessity. One effective way to achieve this right now is by using reclaimed asphalt pavement trap material, promoting recyclability to produce new asphalt mixtures. So why RAP? Firstly, RAP consisting of the old pavement material is valuable for containing suitable substitute to raw material. In this context, RAP utilization diminishes the necessity of virgin binders and virgin aggregate and can be as well used as base course or landfill material. This can save a lot of money. As well, RAP usage reduces the energy and emission inputs required to refine and manufacture bitumen and to extract and transport aggregates from quarry to plant stockpile. This will also save the environment. Now with the problem statement, will RAP utilization lead to a bad performance? This statement is legitimate since performance doubt exists because of the aged binder of RAP that is typically characterized by a high softening point and low degree of ductility, both of which may lead to obtaining brittle asphalt mixture more susceptible to accelerated damage. Secondly, concern about the variability in RAP raw material, especially in the case of unclassified RAP and uncontrolled plant processing. In this case, variabilities in the asphalt content and gradation can lead to inconsistent properties and performance of mixture and difficulties to meet the volumetric requirement for contractors. So the objectives are to characterize the viscoelastic behavior of two asphalt concrete mixture, the first incorporating 15% of RAP and the second a standard or a control hot mix asphalt HMA. Secondly, to assess the permanent deformation or rotting and the fatigue potential of the two mixtures. Thirdly, to probabilistically model the parameter of the sigmoidal function of the dynamic modulus for the two mixture. And this variability will be used to quantify the uncertainty in the performance prediction of standard HMA and RAP mixtures. In the experimental program, two different asphalt concrete mixes were prepared, a control mix representing the standard HMA in addition to a RAP mixture incorporating 15% of RAP. The mix design was performed according to the superpave design method with adherence to its volumetric criteria. Complex modulus testing was conducted to characterize the viscoelastic properties and performance of asphalt concrete mix, and finally, the field performance of pavement structure incorporating the analyzed AC mixes was assessed using MEPDG simulation. So what is the complex modulus testing? Complex modulus testing consists of an application of a uniaxial compressive sinusoidal stress to an asphalt concrete sample and determining the response strain in order to compute the dynamic modulus and phase angle. The test is conducted at different temperature and frequency combinations to cover the full behavior of the material. Then the measured values are used to develop dynamic modulus master curves using the time temperature principle, time temperature superposition principle. So the result of the linear viscoelastic characterization obtained from complex modulus testing showed that compared to HMA, the dynamic modulus of RAP mix decreased over the full range of frequency with a maximum reduction of 21%, 11%, and 4% in the lower frequency range, the middle frequency range, and the higher frequency range, respectively. From a performance perspective, at intermediate and higher frequencies, smaller E-star value of RAP mixtures indicated an improvement in the fatigue and thermal cracking resistance compared to standard HMA. But the inferior modulus in the lower frequency range or at higher temperature marks a reduction in the rotting resistance. Further, the field performance of a flexible pavement structure using the analyzed AC mixes was assessed by the Mechanistic Empirical Design Guide Simulation, which is MEPDG. The Mechanistic Empirical Pavement Design Guide is an international software currently adopted by the majority of pavement design firms. Initially, the software requires three sets of input: the traffic, the climate, and the structure input. In this research, I considered the Lebanese case for evaluation. Here you can see the main inputs to run an MEPDG simulation. In the traffic, we have general and axle loading inputs. We have also the climatic file, and finally, the part regarding the materials of the pavement structure. It's here where the dynamic modulus value are inserted to characterize the asphalt mix used. The result of the permanent deformation or rotting predictions after 10 years shown indicates that the rotting resistance of RAP mixes was reduced by 3.5%. These results come in agreement with the finding of E-star testing that revealed softer modulus at higher temperature for the mixes incorporating RAP. On the other hand, bottom-up cracking result revealed an improvement in cracking performance of RAP mixes by 9.4% compared to the standard HMA. This also aligned with the finding of E-star testing showing stiffer modulus, which is more brittle for the standard HMA. Now, the framework used to assess the uncertainty in field performance of both mixes, the control HMA and RAP mixes, was based on the variability in the dynamic modulus master curves as shown. Firstly, 12 replicates of each mix type were tested, and the measured data was used to develop 12 dynamic modulus master curve using the sigmoidal models expressed by the displaced equations. then a probabilistic model of the 7 model constant, which are alpha, beta, gamma, and delta, A1, A2, and A3, where the probabilistic model for this constant was developed to generate and compute 500 simulated value of the dynamic modulus E star for each type of the mix. In other words, for each of the 500 set of this constant, we will obtain 500 simulated value of E star for the control and the wrap mixes. These 500 modulus value were then used in MEPTG simulation to quantify the uncertainty in the field pavement performance. So as a result, for the bottom-up cracking, the results indicate that the coefficient of variation between simulation of 500 wrap mixes decreased linearly with time from 7.2% after 2.5 years to 5.28% after 10 years. Conversely, the coefficient of variation of the control mixes appears to increase linearly over time, rising from 1.83% after 2.5 years to 2.3% in 10 years. Importantly, it's noted that the uncertainty in the cracking performance of wrap mixes consistently exceeds that of the control across the pavement design life. And this was expected due to variation in the material of unclassified wrap. However, with a variability in performance less than 8%, I think that can refute previous concerns regarding the utilization of wrap material in a new asphalt mixture. Now, regarding rutting, the coefficient of variation or uncertainty in wrap mixtures seem to follow an inconsistent pattern, increasing to a maximum of 4.8% in 2 years and then decreasing to 2.8% after 10 years. The relationship of the coefficient of variation of rutting appears to follow a polynomial relationship with time, as shown. Now, for the control mixtures, the coefficient of variation value in the HMA mixtures seems to be consistent with time and decrease linearly, albeit very slightly, from 2.2% in 2.5 years to 2.1% in 10 years. Overall, both the coefficient of variation value of bottom-up cracking and rutting showed comparable results, supporting the convenience of using unclassified wrap material in a new asphalt mixes. And finally, the conclusion here, we can start by conclusion number 1. So in comparison with standard HMA, incorporating 15% of wrap reduced the dynamic modulus over the full range of frequency with a maximum reduction of 21%, 11%, and 4% in the lower, middle, and higher frequency ranges, respectively. Now, secondly, based on MEPTG predictions, comparable rutting performance can be expected from conventional HMA and wrap mixes with low content of wrap, with a percentage change in the range of 4%. Also, bottom-up cracking results reveal an improvement in cracking resistance of wrap mixes by 9.4% compared to standard HMA. Thirdly, the uncertainty in the cracking performance of wrap mixture consistently and slightly exceeds that of the control mixes across the pavement design life, as expected due to variation in the material of unclassified wrap. And finally, the coefficient of variation value in the fatigue prediction of wrap and HMA mixtures showed comparable results, supporting the convenience of using unclassified wrap material in a new asphalt mixture. And by that, I finish welcoming any question from the audience.
Thank you very much, Dr. Firas Baraj. Dear
Welcome.
connectors, anyone have any question, you can raise your hand and ask your questions.
Yes, Professor George, yes.
Yes.
Very much. Thank you, Dr. Barraj, for this nice presentation.
Thank you.
But while listening to you, I was thinking about the valorization of waste in the region of Middle East now. How you can participate, I would like to say, in the reuse of deconstructed materials in asphalt-like material.
Okay, so for waste material in general, now we are testing wrap material, which is reclaimed asphalt material, and it's showing promising result. We tested the mixture with low content, and now we are continuing with medium and high content of wrap. Also, fly ash was proven to be used also as a filler material. Glass, we have one research conducted on using on the utilization of glass powder also as replacement of fine material with a percentage replacement percentage of 10 to 15%.
Mm.
Bottom ash also can be used as a replacement material of coarse aggregate. So the asphalt industry welcomes the utilization of waste material in the production of new asphalt mixture, and this will contribute eventually to the sustainable development of this industry.
It's very promising and interesting because after many discussion, I think the only possibility in the Middle East to use in place, in situ, due to the economical problems of transportation, crushing, etc., etc. So it's very interesting what you say now. Use the waste material in asphalt industry, maybe in the near future, the only solution for the moment. Thank you
Yeah.
very much.
Thank you, Professor George. Thank you.
We have Professor Hakim.
It's a nice presentation. Thank you so much. Just I need to know from the authors about the model of statistical model. It mean by they use it just only modeling because I don't see the no any scatter in your data, just only linearity and so on. Is there any, for example, let's say that the samples who are used, how many samples you are used in per one mix, for example? Three
Yeah,
samples, two samples.
you can see in the flow chart here, I used 12 replicates. No. Okay, screen shared. Okay. So you can see here, I used 12 replicates for each of the mixes for the control and the wrap mixes. From that, I generated a probabilistic model for the parameters of the sigmoidal model, which by Monte Carlo will generate for me 500 sets of this coefficients. And I can implement these parameters to calculate using this equation the new 500 E star value for the control as well as for the wrap mixes. So I use 12 replicates, which is statistically proven because to derive statistical models from experimental data, you need between 10 to 15 replicates.
Okay, thank you so much. Just only I want to see that. Okay, thank you. Thank you again for your
Welcome. Welcome.
Thank you very much, Dr. Firas Barraj. I think we have more questions. Dr. Ali, I don't know if Prof. Tohami can join us or not.
Looks like he's not going to join because I didn't get any response. So we should proceed. We should proceed. Okay. Since now we are moving to Dr. Muayyad Sabah. Maybe if Dr. Tohami come back, Then I will deliver the chair again to you to present him and to chair his session. Okay, Dr. Salam?
Okay, no problem, Dr. Ali. Thank you very much.
Okay.
Dear
And
connector,
now,
let us continue our session. So I would like to invite my colleague, Prof. Moayed Subah, to moderate the session. So, Prof. Moayed, the platform is yours.
Thank you, Dr. Mous. I will apologize first for my delay. Internet in Syria was totally interrupted. Thank you, Dr. Ali. I want to say I have the honor to head a part of the last session in the first SCCEE International Virtual Conference. Thank you very much. And I suppose we have to move to the next lecture. I don't know if it's available. Engineer Rula Taha.
it's Engineer Ayat Ashur, Dr. Moayed now.
Ayat Ashur is
Yes,
available.
the fourth topic from University of Sharjah.
Okay, it's available, Dr. Ali, or?
Yes, available.
Available. Engineer Ayat Ashur from University of Sharjah. That topic is the investigation, the flexible airfield pavement response using two different analysis approaches. So the floor is yours, Engineer Ayat. Please proceed.
Thank you. I just want to check I share my screen. It's shared already or no?
Yes, Engineer Ayat.
It's shared?
It's shared.
It's here, yes. You can proceed.
Thank you. Good morning, everyone. It's my pleasure
Good morning.
today to present my presentation to this conference. My name is Ayat Ashur. I'm a PhD student at Sharjah University, and my colleague is Hussein Salah, Sham Miro, and Dr. Walid Ziada. I will present our research today on title Investigating the Flexible Airfield Pavement Response using two different analysis approaches. The outline for today's talking will follow introduction, literature review, then objectives and methodology, and result and discussion, and finally conclusion. Starting with introduction, one of the greatest challenges of airport planning and design is to Design is the airport is facilities that accommodate variety of aircraft. The main facilities such as taxiway, runway, and ramps designed to support aircraft. Pavement is the element that supports aircraft with respect to structural load, stability, different operations, and dimensional criteria. Therefore, pavement is one of the biggest infrastructure investment at any airport. And for pavement structure, there are two types of pavement, flexible and rigid pavement. Starting this approach, in this paper, our approach with flexible pavement. Flexible pavement has many advantages, such as inexpensive, duration time is less, and easy to repair, and no joint required. And pavement responses are crucial for determining pavement performance and estimating pavement surface life. Aircraft load on flexible pavement produce two critical responses. The first one is the horizontal tensile strain at the bottom of AC layer, which is asphalt concrete layer. Another one is vertical compressive stress at the top of subgrade, which is contribute to rutting. As we can see, tensile strain at bottom of asphalt layer, it's a big contributor for fatigue cracking. And another stress, which is compressive stress at the top of subgrade, contributes to rutting. And fatigue and rutting to understand it. It's very important for performance of pavement and to achieve permanent pavement structure. Moving to literature review. There is a study in 2019 compared between two specialized finite element program, which is SCCEE and EverFE, to analyze rigid pavement. And comparing both programs showed that deflection and distresses showed a good correlation using both programs. Other study in 2017 used kin layer software to analyze flexible pavement, and this study compared between different section structure, and it recommended this section for giving best number of repetition till failure for fatigue and rotting. Other study in 2015 used WinJolia software to analyze pavement structure for flexible pavement, and this study compared between different wheel interaction and responses on pavement, and also compare different wheel configuration and different speed for takeoff for aircraft. So we find different study using different softwares, but we don't know which software is better or recommended for airfield design. So our objective is to use different softwares to analyze one section of flexible pavement in airfield design. We suggest to use Jolia and KinPave, which is skin layer, on it, to compare between them and to compute responses for flexible pavement. Our study area will be Dubai Airport. We will choose which aircraft for design based on the most frequented aircrafts in Dubai Airport. Our methodology will follow 4 steps, starting with selection of pavement section. Second one is to select the design aircraft. Third one is to calculate responses using 2 software programs, Jolia and KinLayer. And the last one is to calculate number of repetition till failure for fatigue and rotting using Asphalt Institute equation, using the responses from different software used. Starting with phase 1, with pavement section. Our section include 4 layers: AC layer, base layer, sub-base, and subgrade. This is the numbers for modulus of elasticity, Poisson's ratio, and thickness by inch for each layer. Phase 2 is to select the design aircraft. Based on the most frequented aircraft in Dubai Airport, we compare between them. We choose the first 5, which is Airbus A350-900, Airbus A380, Boeing 777-300ER, and Boeing 777-200ER, and Boeing 778. And we compare between maximum takeoff weight, tire pressure, and we calculated tire load for each tire based on axial type and wheel configuration. And we decided to choose Airbus 350-900 because it gives us the maximum tire load. Moving to phase 3, we will use the WinJolia, and we used WinJolia and KinLayer to calculate responses. This is the wheel configuration for our selected aircraft, and this is the mesh which points we calculated the stresses and strain on it. The final step is to calculate the number of repetition till failure for fatigue and rotting using Asphalt Institute equations. Moving to result section, we compute tensile strengths at the bottom of asphalt layer using both softwares. As we can see, the horizontal tensile strain distributed at the bottom of AC layer showed similar trends, but actually it's different values. For the maximum value, we're right under the wheel, and the strain gradually decreased until it reaches at the middle between wheels. This is expected. But the maximum tensile strain calculated were 4.5 times 10 power minus 4 for WinJulia, and 7 times 10 minus 4 using Kinlayer software. For compressive strengths at the top of top grade, it should different trend, but similarly as at the edges. And Kinlayer software also showed maximum stresses compared to WinJulia. For calculation number of repetition till failure, as we can see, the Kinlayer give maybe doubled the value for WinJulia software per number of repetition till failure for fatigue and rut. For conclusion, both software have a good agreement with each other regarding stress distribution trends, but actually Kinlayer software showed maximum value of stress strain compared to WinJulia. This may be this difference because WinJulia depends on layer elastic theory, but Kinlayer is finite element method, and this maybe give us as Kinlayer is most appropriate software or most accurate than WinJulia because it depends on finite element approach. Our recommendation to, because of this big difference between two softwares, which is already used by literature, we suggest to extend our study to, or another study, to use third software to judge between them and to determine which one is accurate. And the other thing, we can use different pavement section to compare responses. Thank you.
Thank you, Engineer Ayat. I open the, give me a minute. I open the discussions. Please, Dr. Faraz Barraj, raise the hand, please proceed.
Okay, thank you, Ala, for the presentation. I have one question, and actually you mentioned it in the future perspective of the work. I see the work conducted is actually a good work. However, it lacks the definitive status. So still from the study, we cannot know which software is more accurate. I believe that this work should be extended to comparing the prediction of the WinJulia and the Kinlayer prediction to a field or field performance monitoring.
Yes,
Okay, and by that you can maybe have a clear indication which of the model to be used. This is maybe better than using a third software because I see here a huge difference. It's almost the double result is obtaining between one software and another one.
Yes. Okay, we can add some of field assessment for this.
Yeah,
And
this is maybe in
actually,
another
in
study.
literature, we see studies used WinJulia, another studies using Kinlayer, and no study of that compare between them or use different criteria.
Yeah, yes, that's good. And if you have the previous studies, this can help you. And by that, I mean you can just see the accuracy of routing or predicted using both software and the results that were obtained on the site. I believe there are studies where a field performance was compared to the result obtained from softwares, and by that you can see which one is more accurate, and by that you can recommend this software and maybe omit the other one because it's giving a large difference in results.
Okay, yes, I see. Thank you for your comment.
Thank you,
Okay.
Ella. Thank you.
Yes. Satisfied, Dr. Firas? Finish?
Yes, great.
Yes. Maybe another question. So meanwhile, I want to ask you, Ayat, for your a question for non-specialists. are the both software based on finite element technique or built-in models? Could you brief us what the both software can deal?
Both software can give us a stress and strain distribution. Actually, WinJulia depend on layer elastic theory, not a finite element program, but KinWave or KinLayer depend on a finite element program. So it seems to me this the most accurate to use, and it required a lot of inputs than WinJulia. So
that seem to have such built-in models for
yeah.
like the geotechnical software that deal with elastic theory in the soil layers.
Yes.
Could the both software also use for soil mechanical investigation or just for this material?
I think just for pavement.
Pavement and roads.
Yes.
Roads and pavement.
Yes.
Roads, what we can say, roads techniques.
Roads, yes.
Yes. Thank you. Another question, please. So, no question. So, is Engineer Rula Taha ready now? Thank you, Engineer Ayad. Let's move to the second speech.
They will
Rula
play her
Taha.
video, Professor. She
Video
recorded
is
a
ready.
video. Yes, yes.
Let me introduce the subject. Rula Taha from Al-Bas University in Syria will talk about experimental and analytical evaluation to strengthen RC beam using verocement under torsions. Please, let's start the video.
Good time, everyone. Thank you for being here today. Our research is experimental and analytical evaluation to strengthen RC beams using ferrocement under torsion. The rehabilitation of building is an important consideration, especially in developed countries where replacing deteriorating structure isn't always the most effective solution. The Guide for Design, Construction and Repair of Ferrocement, ECI 549, defines ferrocement as a type of reinforced concrete that is commonly constructed of cement mortar reinforced with closely spaced layers of relatively small wire diameter mesh. Because of the circular nature of torsion, ferrocement as wrapping material would be protective to protect the stress structure against torsion. The experiment tests are critical to improve the accuracy prediction of analytical models. This study aims to investigate the torsional resistance capacity of the beams that were strengthened by ferrocement from 3 and 2 sides, and by utilizing SPR as a connection material when it is added to mortar as an emulsion. Also, to compare the experimental results with finite element analysis using Abacus to verify the validity of the analytical model. 6 beams with cross-section 125 and 250 millimeter were cast. All beams were reinforced with 2 bars of 12 millimeter at tension and 2 bars of 12 millimeter at the compression side with yield stress 445 megapascal. Also, beams were provided with stirrups of normal milled steel, 8 millimeter diameter and 100 millimeter spacing with yield stress 408 megapascal. To achieve the required mechanical properties, many tests were conducted. The tested beams were divided to many groups. Each group had 2 beams. BN group was considered as control beam, while B1 group was wrapped from 3 sides, and B2 group was wrapped from two sides. The details of control and strengthening beams showed in this table, where the wire mesh diameter for ferrocement is 2.5 millimeter. The opening size is 20 millimeter, and the yield strength is 568 megapascal. To implement the ferrocement strengthening system, the beams were sandblasted and drove-in surfaces, then cleaned using compressed air and water. The necessary length of mesh layer was cut and bent to the required shape. Our mortar mixture was designed as an integral adhesion to achieve the desired connection by adding SPR as an emulsion with 20% of the cement weight. All the tested beams were subjected to twist from both ends using two opposite twist arms. 5 sensors were installed to record displacement as the load increased. Then the angle of twist were calculated. All beams were subjected to testing to determine their cracking torque, ultimate torsional strength, and angle of twist when the first crack is appeared and at failure point. From the following table, we can see that cracking and ultimate torque of strengthening beams B1 and B2 considerably increased in comparison with the control beam, while the twist angle's value significantly decreased. From the figures, we can notice that the control beam torque twist relation displayed linear behavior, while the curve of strengthening beam is characterized by 3 stages. Also, it is clear that torsion behavior of the strengthening beams and cracking control ability have improved. The growth of cracks are reduced. 3-side strapping maintained its connection with RC beams with only minor cracking, while the ferrocement laminates with 2-side strapping showed partial sloping with semi-deep cracking. The analytical study. 3-dimensional models of control and strengthening beams by ferrocement from 3 and 2 sides were modeled using Abacus version 6.14. We used the element C8D3, which defined by 8 nodes having 3 degrees of freedom at each node to model concrete beam, steel twist, arms, and mortar. While we use the element T8D2, which defined by 2 nodes with 3 degrees of freedom at each node to model reinforcement and wire mesh. The effect of SPR as connection material is determined by friction coefficient, which was used 0.1. All the material properties matched those utilized in experiments. From the figures, we can notice that failure pattern of analytical model for control beam was similar to the experimental results. Also, the formation and growing the cracks are very similar. In the same manner, we can see that a failure mode of experimental and analytical curve of B1 beam is closed. Also, the cracks observed at the midspan of the beam in both cases, despite there was a slight decrease in the experimental twist angle. The torsional behavior of both experimental and analytical tests of B2 group is comparable. The analytical curve slightly divides for the experimental one. The results of analytical and experimental tests are presented in this table, where we can see the matching results. From the above mentioned, the following conclusions are drawn. The strengthening beams with ferrocement satisfiedly improves the torsion behavior regardless of the wrapping type. Experimental results showed that strengthening from 3 sides enhanced torsional behavior by 15% more than that achieved by strengthening from 2 sides. The utilization of SPR enhanced adhesion between the RC beams and ferrocement, whether applied from the 3 sides or 2 sides, and maintained the connection without complete collapse. The failure mechanism of control and strengthening beams is accurately modeled using finite element analysis by Abacus, and the torsion behavior predicted is very close to that measured during experimental testing. While the beam wrapped on two sides led to a slight increase in stability, the U-shaped wrapping enhanced stability by notably reducing both crack formation and ultimate twist. The reference, thank you for your listening.
Thank you, Engineer Rula. Are Engineer Rula available?
Yes, I am here, Prof. Thank you
Yes,
for your.
I open questions. Questions, please.
If you allow me,
Yes,
Dr. Muayyad.
Professor George Warde. Yes, please, Dr. Ali.
Well done. Professor Warde, please, after you, after you.
Yes, please.
Professor Warde, you are muted.
Sorry. Thank you, Professor Sobh. Thank you, Mrs. Taha, for this very nice presentation. Really, I appreciate it. But if I'm not mistaken, for the numerical part, I didn't see the material models that you used. As you know, for numerical analysis, the results are influenced by the stress strain laws, and especially in tension, and more especially in the post-cracking phase. So what did you use? How did you define the damage in these models?
We use for the concrete, we modeled as CDP model or concrete damaged plasticity to control. The connection between ferrocement and the RC beams, we modeled as tie model. That's it. I answered the question.
Okay,
Doctor?
very good. The latest part, how did you define the damage evolution? CDB is a very good model, but very sensitive to the damage and the plastic strain evolution. So how did you define these parameters?
We tried the connection between two. We tried to get a traction coefficient to get the.
Could I interfere in the discussion? It seemed to be that they define only the strengthening. They don't deal with the failure status, or they not continue to the failure status. So what I'm seeing is that.
Very good. Thank you. Thank you, Rula. Thank you, Professor.
Thank you, Doctor.
So we move to Dr. Basil. Dr. Basil, you are muted.
Thank
Now,
you,
please.
Professor Sabah. And I would like to thank Rula for this informed presentation. Actually, I am interested in economic factor. I just want to ask Rula, did she take the economic factor into account when she chose ferrocement over other alternative? And thank you.
Thank you, Dr. Basil. As I understand from your question, ferrocement as strengthening beams doesn't need or required qualified workers, and its ingredients are easily available. Consequently, the cost of ferrocement as strengthening techniques is inexpensive, and I think it's or I'm sure it's cheaper than other strengthening techniques.
Satisfied, Dr. Basil?
Yeah. So Rula, make sure that she choose the most let's say it's the suitable alternative regarding the cost.
Yes, I believe I do.
Yeah, thank you.
Thank you, Dr. Basil. Another question? I have advised Engineer Rula,
Yes, Doctor.
please, if you want to proceed with this research, I advise you to comment. First, what Dr. George Ward commented before, proceed with defining failure or damages status.
Yes.
Second, I advise you also to deal with this state as composite structure because of differences between elasticity of different material. Then you
Yes.
can now define or deal with three type of failure. One, the basic material. The second, the SBR connection. And the third, the verocement material. If
Yes.
you go in those both direction, maybe you can get for us formula to calculate and strengthen the concrete with the verocement. Is an interesting topic. Wish you the best. And if another question, Dr. Basil? Dr. Basil, you raise the hand.
No, doctor. No. I have no question.
Thank you. Thank you,
Thank
Engineer Rula, and good luck in the further researches.
Thank you, Doctor, for your advice, and I will take it sure.
Yeah, thank you. Bye. Let's
Thank
move to the
Professor
yes,
Muayyad, sorry for interruption, but it looks like the last two participants are not here. We tried to contact them since yesterday. Oh, okay. Maybe we have one of them now, Dr. Yasmin. She just entered. So hopefully the last topic will be Dr. Yasmin. Let's wait just a second to make sure she... Dr. Yasmin, are you here?
Yes, Ali, good morning.
How are you doing? Hope everything is fine. Then you can proceed, Professor Muayyad. She's the
Yes.
last participant for today.
Yes, Dr. Yasmin, you are welcome. We are waiting for your topic, use of photo catalytic. I don't know if I spell it right. Photocatalytic mortar for BTX and heavy metal removal from industrial wastewater. Interesting
Hello.
topic. Yes, it's. Please proceed.
Hello, Dr. Muayyad. Sorry, I thought that my time is like 1 hour later than that. So should I proceed now? If yes.
Yeah, you can proceed, Dr. Yasmin.
In fact, I need to join from...
Lebanon. Yeah, I introduce your topic. You can proceed now if you are ready.
Okay, so I just need to join from my laptop because I was joining just to see the timing of the conference, how it's going, and
your
I
times
have...
are waiting.
Oh, okay. Yeah, I'll join. Thank you.
Meanwhile, let's seize this chance to listen maybe for some suggestions, some feedback about the conference. Professor Muayyad, Dr. Salam, Professor George, Dr. Khatib, Professor Hakim, all the participants. What do you think? Do you have any suggestions, any feedbacks?
We have to talking about the next conference, not the first conference is finished.
No, hopefully the next version of this conference will be much better than this one. We learned a lot from this experience, and hopefully next year we're gonna do something more special.
Dr. Ali, plus I want to suggest to give more time for preparation and testing. Maybe could be more let's before the next conference, let's make a semi-conference, a test that we can
make sure of the
summarize
connections like this, you mean?
connection and something like what we can call result or suggestion, what this conference can benefit for the other institutions, what we will review and take, for example, best article, best participation, best something like that. Let's make something social in the conference that make more interesting. I don't know.
We already had 3 hours, and we're gonna announce the winners. The organizers chose 3 winners, one from each category. But yeah, maybe next year we can extend this type of social activities. You mean to make it take more?
Yes, more social. Let's make more interactive. Let more result best showing tools, something like that. Summarize each session by one of our specialists, not only by participant, because it could be more useful. I don't know if you are going to publish or this article in one publishing.
The articles will be peer-reviewed. It's a double peer review, and they will be published in a Scopus Proceedings. It's a Scopus and of Science Proceeding Journal. Yeah, but after being reviewed, and not just gonna be published directly. Professor Wadi, do you have something to add? You unmuted yourself.
Professor Hakim want to add something. Please.
Yes. Yeah, thank you so much, Professor Mai. Yes, of course. I think that's we have to also sharing some companies, big companies, and so on.
Yes.
Yes, like exceptions. Yeah. Ready-mix concrete, for example. Yes, in my opinion, this is in many conferences, even in ACI convention, up to the international conference. So just there is a sectors for the companies and so on, and producing, because we are producing. Let's say that we can fiber. We use fiber, but who's produced the fibers? You know, we don't produce the fibers. So we need some companies that they, for example, they show us how the proceedings is going on.
The practical part of the topic, not just the theoretical part. You mean? To talk about practical issues.
If we find some sponsors, also could be from the field we are. Also research on something like that. I agree with you.
Yeah.
Professor George, you want to add something? You're raising your hand.
Yes. I don't know if another professor would like to tell something before me. Professor Tarauni is here.
Professor Tarauni, Professor Khatib, maybe.
Sorry,
is
okay,
here
I
also.
don't see all the audience on my screen. So, Professor Khatib.
Good morning, everyone.
Good morning.
It's really great. I mean, the conference is normally about gathering and meeting people, whether it's face-to-face or obviously face-to-face is better. But for example, if I'm talking to Professor George now or Professor Hakim or everyone else, is really it's a good way to keep communicating with each other. This is really important, and hopefully this first conference will obviously pave the way for other wider maybe conferences as well. Now we started to know each other. Maybe we start to obviously inform our connections as well. I know Professor Hakim, Professor George has done lots of work in that as well. Maybe myself, I did not too much, maybe a little bit, but hopefully next time I'll do a little bit more. And hopefully it will be even a wider participation next time. But I mean, online is also good, for example, because if you want to travel, it costs lots of money, and some places they don't have enough resources. So online is good, but face-to-face is better. Or the ideal situation is the mixture of both.
Thank you very much. Thank you very much.
Thank you,
I
Prof.
would like to thank you all if I can share my experience in this conference. I really appreciated the involvement of Ali Al-Jihami first of all, but the organizers, as I said yesterday, which are always in the background to manage everything. Yes, Professor Khatib, we started to work together since 2 years, Professor
Yes.
Abdelkader. In this community, I will call it community.
Yes, yes.
Arab, Middle Eastern, North African, and European. Even from India, we have now many colleagues. If we want to go ahead, we must find an association who support us, like the RILEM or the FIB. As Ali and the organizers know very well, we tried to contact the FIB, International Federation of Concrete. If we have the support of the FIB, so we are
Things will be easier.
It will be easier. So the advice of the FIB now, you can propose or you can develop a chapter in the Middle East. Maybe in Lebanon now will be easier, and unfortunately for the circumstances in Syria, we can develop a chapter in Lebanon for the FIB, and in this case, we will be known at worldwide as a partner of the FIB. All our results will be published officially, will be discussed within the development and the revision of model codes, of standards, everything. We are trying, but we need the support of everyone. To be honest, we tried to contact the FIB of Dubai, Ali, if I'm not mistaken, but unfortunately, we didn't get any feedback. I will take 1 minute, Madam Jabali, to finish. On behalf of all Syrian researchers, I would like to thank the organizers, Professor Jamal Khatib and Professor Ali Jihami, for the opportunity that you gave to Syrian young researchers to valorize their works. We are very grateful, and all the world are missing me now to say thank you again for the happiness that you gave to Syrian researchers. Thank you very much.
Thank you, Prof. Wardi.
Thank you, Dr.
Yes.
Wardi.
Back to you, Professor Muayyad. Madam
Yes.
Jabal is ready.
What I am saying, Yasmin is ready now to participate in discussion or proceed with your sessions. You are muted, Yasmin. Please open your microphone. Yes, please.
So good afternoon, everyone. Thank you for this opportunity today to share good insights about one of the MS thesis project that was done concerning the application of photocatalytic mortar for BTX and heavy metal removal from wastewater. I just want to say that one of our brilliant students, Rawan Ghanim, will be presenting her work, and then we will stay here if you have any questions. So Rawan, please introduce yourself and the floor is yours. I'll be sharing my screen and Rawan will be presenting.
Hello, everyone. Thank you, Dr. Jabali. Thank you all for this opportunity. It's a pleasure to be presenting in this conference.
Can you see my screen?
Yeah,
yes,
it's seen. It's seen.
Okay.
It's shared, yes.
So, thank you. In fact, yes, concrete can help treat wastewater. How? This is the scope of our research entitled The Application of Photocatalytic Mortar for BTX and Heavy Metal Removal from Wastewater. Kindly next. So the objective of this research is to test the impact of the catalyst or the photocatalyst on the mechanical properties of our concrete and the impact of this catalyst on BTX degradation and heavy metal absorption. Next, please. So wastewater treatment has been vital. Extensive research has been done on the topic since a while ago. And generally, it can be categorized into physical, biological, and chemical. The scope of our research covers photocatalysis, which is a branch of chemical treatment. But what is actually photocatalysis? So the next slide, we see that photocatalysis is a mechanism that relies on the presence of a semiconductor or a photocatalyst. In our case, it is titanium dioxide, also known as titanium, that is excited by UV photon energy, produces hydroxide radicals that are in turn responsible for the degradation of organic pollutants. How does this process actually happen? In the UV light, the photons hit the TiO2, and the electrons are excited from the valence band to the conduction band. Definitely, the bandwidth of the UV photon light should be greater than that of the TiO2. When the electrons are excited, the H+ hole that is left in the valence band reacts with hydroxide ions to produce hydroxide radicals. These hydroxide radicals react in turn with the organic pollutants and degrade them into carbon dioxide and H2. Now, in this research, we focused mainly on the removal of BTX and heavy contaminants found in water. Several research was done on conventional techniques, but limited research studied BTX removal and not from water. So this is what will be covered in our results to discuss heavy metals. Heavy metals is a great concern in wastewater, and it is non-biodegradable. It does not react the same in photocatalysis. BTX are organic, they are degraded, while heavy metals are mostly or sometimes photo-reduced. So knowing the large impact on human health, the WHO has set certain limits for their presence in water. We will be covering several heavy metals like lead, mercury, chromium, nickel,
Sound quality is poor.
photocatalysts.
I don't know if it's recorded or she speak directly.
Okay, can we move on, please?
She's speaking directly. She's online.
Maybe
Slide,
she has to fix the distance to the microphone.
Rawan, if you can just fix the distance to the microphone. Okay,
so
thank you.
what are
Yes. Reduce.
actually using? In the coming slides, we can see that we have prepared a different I'm speaking directly.
Rawan, your voice is lagging.
There's a problem in the connection.
Yes, I think.
It's poor connection, maybe.
Can you do it from your side, Dr. Yasmin? Because
is it better this way? Can you hear clearly? Okay, thank you. So we have decided to integrate inside of the concrete mix. So we have prepared a control mix that contains 0% of titanium dioxide, 1% of.
Dr. Yasmin? Dr.
Yes.
Yasmin, the connection is very, very poor. We can't hear anything.
Yes, I'm just trying to connect with Rawan. Maybe she can use the code tree. Just give me 1 second and I'll get back to you.
Okay.
Take your time, Yasmin, because we have some of the participants missing.
It's getting any better. Can you confirm if my voice is getting clearer?
Now is clear.
Yes, now it's better, Rawan.
Now is clear.
Okay,
Proceed,
perfect.
please.
Thank you. As I hope you heard the part where I was mentioning the percentages of titanium dioxide. So we used 1%, 3%, and 5% by mass of cement materials we used in our mortar mix to obtain a medium strength concrete of water to cement ratio around 0.5. Next slide, please. Okay, so these are the tests performed on concrete. We performed the flowability test, and we tried to maintain a constant flow for all of the mixes. And on hardened concrete, we performed compressive strength, flexural strength, and water absorption at 28 days of casting. Next. At the University of Balamand, it is a field reactor equipped with the UV lamps, so where we can put the beakers is completely sealed to proceed with the experiment. After we prepared our concrete blocks, we have to prepare the producers of pollutants. So we prepared 6 different mixes, 3 with BTX at low, medium, and high concentrations, and 3 with heavy metals, also at low, medium, and high concentrations. So in each batch, with the 8 to understand the impact of the titanium oxide percentages on the removal of these. Next, please. Okay, so to understand or to verify our first objective, which is to understand the impact of the photocatalyst on the mechanical, it was clear that we have an increased titanium dioxide that helps in producing the concrete. This, when the percentage of titanium is increased, we can see a decrease in the compressive strength. And this is explained by the fact that the filler property, because the replacement is by percentage of cement. So the concrete will start to lose its properties. We do not see the same behavior with white cement because it is mostly a decreasing trend. So the optimal percentage is 1% titanium for gray cement for the best mechanical compressive strength properties. In the next slide, we can see that approximately the same behavior was visualized with flexural strength. Finally, as for the mechanical properties, we can see that the water in the slide after, with 1% titanium, we have a decrease in the water absorption, and followed by a gradual increase with 3% and 5%. The decrease in water absorption can be seen by the fact that the matrix, which is in line with the compressive strength properties, and as the titanium was increased, the capillary action inside of the concrete increased, which allows more water absorption. The results are in line between gray and white cement, but in gray cement, the variation is more clear. To see the effect of this photocatalyst during the testing period, certain time intervals, and were tested using gives the absorption as a function of the wavelength. Next slide, we can see that in the first 30 minutes, there was a complete degradation of the BTX, followed by a slight increase as time progresses. The decrease in BTX at this certain wavelength shows that the photocatalysis reaction is actually successful and BTX is being degraded. But the increase may be attributed to the fact that other byproducts are being produced at this same wavelength that need to be further verified using other techniques. Next, please. This is an enlarged view of at lambda equals 8 nanometers. The behavior was the same with other percentages, but with 1% we have attained optimal results. Further, please. The same trend is observed at lambda equal to 6 nanometers. Now this is to summarize BTX. As for heavy metals, also tests or samples were taken at certain time intervals, and they were tested using the ICP-MS. It was obvious that we had a decreasing trend and approximately above 95% removal of most of the heavy metals. Definitely some were not responsive to the photocatalyst, but several heavy metals were highly responsive, and we achieved the maximum drop at 120 minutes, and the mixes containing 5% titanium were the most efficient in the absorption of heavy metals. Now we can see sometimes we have a absorption-desorption. Sometimes it drops and increases, but this was only with low percentages. With high percentages of titanium, we can see full absorption of heavy metals and complete removal at 120 minutes. Okay. Finally, we can conclude that gray mortar, cement containing gray cement, mortar containing gray cement with 1% of titanium had the best mechanical properties, showed great results with the BTX degradation, and mixes containing 5% titanium showed best results with the removal of heavy metals. Now, there are some for further study. We noticed an interesting fact that the matrix itself, the cementitious matrix itself, has an impact on the removal of some contaminants, and this is to be further studied, and also understanding the reasons behind the production of byproduct which are causing an increase of the absorption of PTX. Okay.
Thank you.
Thank you.
Thank you for the presentation. We are sorry for the poor connection. Maybe that will guide us for the next conference, that maybe we have to go to another platform to make this conference. Please, Professor Hakim, you have a question. Please proceed. You are muted, please. Yes.
Thank you so much. Maybe Professor Jamal. Okay. Thank you so
Maybe
much.
after you.
Thank you. Thank you so much for your presentation. Just only we see the slides more than because there's some knowledge. I don't know what's happened. Maybe due to the connection, as Professor Moeed say. So we have to also improve. This is in futures. This is 1 hour of recommendation
Yes,
in this
that's
conference.
right. We have to, yes, some other platform can deal with poor connection.
Can you show to me, please, the compressive strength? Or the slides for the compressive strength. You know, this is I want to. The compressive strength. You see, So what do you think about this? There is a control, and we have 1%, 3%, and 5%. So I don't know why you use it 5%. Even 3% is good. So I don't know, overdosing. It mean by it is in my opinion is costly. So why you use it 5%? Even the 3% is the same as the 5%. This is I don't know. And you give also the name of gray cement. I don't know. This is a new terminology or something like this. You have to say cement OBC or white cement OBC, but not gray and so on, and you know that. So we have to keep to the constant terminology, please. Okay, thank you.
Yes, sir. Please. You get the question?
Maybe the advisor.
Yes, exactly.
Yes.
Dr. Yasmin, you may answer if the connection is poor.
Maybe Dr. Yasmin, yes.
Okay. In fact, okay, concerning the terminology, we're just using this to label some of the mortars and to create difference between the labeling. This is first. Concerning the percentages of TiO2, in fact, the study started like 3 years ago. We started working first on TiO2 paste, and we started with like percentages of 1, 5, and 10. And then when we noticed that the best performance is between 1 and 5, we tried to work on reducing those percentages to 1, 3, and 5, and to integrate the TiO2 in the cementitious mix itself. So we added 5 because we were testing, and we want to, for sure, we want to stick to the lowest percentage, and we are happy that we got the best results with the lowest percentage. So now we are working on 1% onward, and maybe on decreasing also this 1% to 0.5 and check the impact. So thank you for your comment, and I hope I answered your question.
Yeah, thank you. Satisfied, Professor Hakim? Do you have another question? Yes, Bruce. Thank you. Bye. Let's move to Dr. Jamal Khatib. You are muted.
Thank you, Professor Moeed. Thanks for the opportunity. Yes, maybe I missed something in the presentation, maybe not, maybe because of the quality and so on. Dr. Yasmin, I'm wondering whether you did some leaching tests, since you've used this in mortar and so on. I thought leaching might be one of the tests, please. And did you try to compare it with, say, photocatalytic technique that you've used?
You are muted again.
For this study, we didn't do any leaching test, although we did it before when we were working on the paste, on the TiO2 paste. So yes, it's one of the perspectives of this work. We will do the leaching for sure. But this time only with 1%.
Thank you. And the other thing is, do you think using the photocatalytic technique is it expensive, for example, compared to, say, other traditional techniques for wastewater removal?
In fact, our Dr. Jamal, our aim was to create a mix in which TiO2 is already mixed, and you can buy it from the market as a mix, as a ready-to-use mix. So no, it's not expensive with 1%. And as I told you, now that we see that 1% is a good percentage to go with, we want to try the lowest percentages and to see if, like with 0.8, 0.5, it might give the same results, and then we will go with this mix.
One last question, please. It's maybe my lack of knowledge in this topic. I know they use they use photocatalytic to clean the glass for windows in buildings and so on. So I'm assuming you are using something similar. But you are using it inside the mix as opposed to the surface of concrete. Is that correct?
Exactly. Correct.
So in the future, do you think that's fine because the surface is something different. So in your case, you are using it inside the mix to remove to absorb the contaminants.
Exactly.
Okay.
We used it before as a paste, as you said. We used it before as a paste with different thicknesses, and it showed very good impact. And because we heard a lot, like, for example, in the case of heavy metals, many wastewater treatment plants are suffering from the issue of heavy metals removal. So we were trying to find a way, maybe if you do the tank from the beginning with this ready-to-use mix, and with the help of the solar radiation, it will create an impact in reduction of those heavy metals.
Yes, it's a good area of work, of course. Yes, continue. Thanks. I know you're doing great work in the chemical engineering department at Balaman. So yeah, well done.
Thank you. Thank you.
Thank you. Bye.
Bye. Thank you, Professor Jamal. We are moving to Ruba Al-Said. Please proceed with your question.
Hello, everyone. Thank you for your... Hello? Sorry,
yes, we're hearing you.
Yes, we can hear you clearly.
Professor Yasmin, thank you for your presentation. Unfortunately, because of the connecting or the connection problems, I haven't seen the error bars in the graph, especially for the evolution of the compressive strings. Do you think really if you put this bar, do you think that there is an evolution, or it's just the uncertainty of measurement?
You want to see the bars for the uncertainty here and the compressive strengths?
The connection maybe is.
Sorry, I didn't
yes,
get the
yes,
question.
it was the
because
question,
the voice
Professor
was
Jabal. Yes.
Yes, we have.
If we put the bar errors, do you think that there is an evolution or just the uncertainty?
No, we have already the graphs where we have the bar errors, and this is only to summarize the results. And no, there's no evolution, no big difference between the values that are shown here and the uncertainty values.
Thank you.
Okay, Ruba Said, another question. So, is there are there another question for Anders? So maybe I will thank you, Dr. Yasmin.
Just one last word. Last word. I would like to highlight that this work, as in its first part, won the award of the لنقابة المهندسين يعني for the Boards of Engineers. Yes, Ords of Engineer of Tripoli. So we won the first award for Best Environmental Impact Project in 2022. So and we are still working on it, and also even if you see the reactor, we did the reactor at the University of Balaman. So it's we did all the work from scratch. We did our own reactor, and it started with this very small reactor at the beginning, and then we made it big to do more and more testing specifically for wastewater. So we don't have only one reactor but more, and we're still working, as I said. Not only on creating this ready-to-use mix, but also on testing for different type of photocatalysts. So not only the TiO2, but maybe ZnO2 and others. So just to highlight this issue.
Yes, thank you. It seems that is a great work. Unfortunately, we couldn't follow so much because of the poor connection. I want to say to Professor Warde, maybe we have to think about this problem later on to choose another platform. I personally have a lot of problem with Zoom also here in Syria because most of people use VPN to allow them using Zoom connection. Thank you, Dr. Yasmin. Thank you, everyone. Maybe if the last participant not available, I don't know Bashar Al-Shuqair from Iraq is available or not.
No, I think this is the last presentation in our conference, if I'm not mistaken. Thank you, Professor Muayyad. Thank you, Dr. Salam.
Thank you, Dr. Ali. I overhead the heading of the conference to you. Please proceed.
Thank you so much for your efforts. I just received now the results regarding the award winners in our conference. We had the privilege to receive more than, as I mentioned before, 60 abstracts. 35 of them continued to the second stage, and 32 reached the final publication stage. The papers will be published in Scopus, as mentioned before. However, we had to choose 3 winners, 1 from each category. I'm going to remind you the categories were the Doctoral Research Excellence Award, the Master Research Excellence Award for Master students. The first category is for PhD students. The second one is for Master students. And the third one is the Research Excellence Award for Low-Income Country Scholars.
Ali?
Now, yes, Professor Wardi.
Do you can give 32 awards or not? It's not possible.
Wallah, if it's to me.
Because all the participation really
Exactly, definitely. We had lots of high quality research, and it was not easy to choose the winner actually. Really, in some categories we had 2 to 3 participants competing together, and it was about fractions in terms of the marks or grades.
If I'm allowed just to say that the committee who selected the winners was a natural committee. We don't know everyone in this committee. We don't know anyone in this committee. Me, Ali, and the organizer were a part of this selection. I would like to mention this.
It was a neutral committee. Yeah, exactly. So, let's start with the Doctoral Research Excellence Award. We have here, the winner is Engineer Basil Buckley from the Higher Institute of Earthquake Studies and Research, Damascus University, for his research on coupled damage creep effect and reinforced concrete beam. Engineer Buckley, well done, great job. Many congratulations. You did great in your presentation, your paper. The comments received regarding your paper also shows that your work was done perfectly.
Thank you very much, Dr. Ali.
Thank you,
Dr.
Thank you very much, Dr. Ali.
Very good student.
Thank you all. Welcome.
Thank you very much. And I would like to thank you, Dr. Ali, for the great and I would like to thank also all the organizer, and of course my supervisor, Professor Hala and Professor George. And I hope I could give a good image about the Syrian researcher.
You did.
Thank you.
You did. I can guarantee that you did. You
Thank
did
you.
well.
Thank you. Thank you very much again, Dr. Ali. Thank you.
Thank you. Okay. So this is for the Doctoral Excellence Award. For the Master's Research Excellence Award, the winner is Engineer Sarah Eid from University of Sharjah for her research on integration of titanium oxide nanoparticles and carbon nanotubes for enhancing asphalt binder properties. Congratulations, Engineer Sarah.
Thank you so much. Thank you. I'm really happy for the opportunity. Thank you so much. I really appreciate it.
Congratulations,
we are
Sarah.
glad too.
Thank you.
Good work. Okay, and now the third Excellence Award is for the low-income country scholars. And here we had a discussion, actually, the committee. The selection was not easy here, but at the end, they had to choose one winner, and the award goes to Dr. Bara'a Faraj from Al-Ba'ath University.
Bravo.
For her research on
Congratulations.
the effect of the type and location of irregularities on the seismic response of dual structural systems. Many congratulations, Dr. Bara'a. You deserve it.
Congratulations, Dr. Bara.
Thank you, Dr. Ali. Thank you. I would like to express my happiness to be part of this wonderful conference. And I would like to thank Dr. Ali Dihami and Dr. George Wardi.
Thank you, Bara'a. Well done. Congratulations to all our award winners. Your work exemplifies the spirit of the innovation and excellence that we celebrate at this conference. Now, as we conclude the first SCCEE International Virtual Conference on Building the Future, Innovations and Challenges in Sustainable Civil Engineering, I'm filled with pride and gratitude, actually. Over the past few days, we've shared valuable insights, explored groundbreaking research, and forged new connections, all in the spirit of advancing our field and building more sustainable future. I extend my heartfelt gratitude to everyone, actually, who contributed to the success of this conference. A special thank you to our organizers at Scientific Steps International Publishing Services, Ms. Maya Jindi, the CEO of SSG and the head of the organizing committee, Mr. Fawaz Rifai, the marketing manager, Mr. Ahmed Sulaiman, the chief operations officer, and Mr. Muhammad Rifai, the editorial manager, for their exceptional efforts. We are also deeply grateful. Dr. Maya.
Thank you, Dr. Ali. Thank you. Thank you for your nice words. And
thank you.
I want to say something. I want to say for everyone, thank you. As we reach the conclusion of our first international virtual conference, I want to extend my heartfelt thanks to our guests of honor. Firstly, His Excellency Dr. Talal Abu Ghazali. His presence added a valuable value to our conference. And to our partners from all universities, the University of Balamand, Northern Technical University, Abu Dhabi University, Damascus University, Tishrin University, and all of the universities that participate with us, and all the partners. I want to say your support and contributions have been invaluable. Also, I want to express my deep gratitude to our conference chair, Dr. Ali Jahami, and our co-chair, Professor George Wardi. Thank you. The head of the scientific committee, Professor Jamal Khatib. Thank you all. Special thank goes to our keynote speakers, the professors, Professor Said Kinai and Professor Joseph Asad, Professor Hakim Abdelgader. Thank you, Professor Hakim. Professor Serkan Kerjiz, Professor Arizki Hamo. Your expertise and insights have significantly enriched this conference. I want to extend a heartfelt thank you to my team and everyone who worked behind the scenes to make this event reality. Mr. Ahmed Sulaiman, thank you. Mr. Fawaz Rifai, thank you. Mr. Muhammad Rifai, thank you. And your teams also. To all the researchers and scholars and participations, thank you for your engagement, your questions and your contributions, and congratulations for the winners. And finally, I want to say thank you all once again. I want to see you in the next conference, and thank you.
Thank you so much, Dr. Maya, for this speech.
Thank you.
Please, before leaving, let's take a final screenshot. Kindly open your cameras. This will be a special memory actually for me, being the chair for the first time in my career. So it will be something to be remembered forever. So let's open the cameras, please, for a final screenshot, and then I'll close the session.
Dr. Sultan Tarauna.
Dr. Sultan Tarauna, yes.
Engineer Fatma Diab. Engineer Ala Sukkari.
Dr. Firas, Dr. Majid Al Mahmoud.
Engineer Tala Murtada. Kindly open your camera.
Mr. Ahmad.
Yeah, thank you very much. It's done. Thank you very, very much for being part of this event. And
okay,
we are excited to meet you again in following events, Dr. Ali.
So in closing, I encourage each of you to apply the knowledge and insights gained from this conference in your work. Let's continue to collaborate, please. Innovate and push the boundaries of what's possible in sustainable civil engineering, because together we can drive meaningful change and create a better future for generations to come. Thank you once again for your participation and engagement. It has been an honor to host this conference. With that, I officially close the first SCCEE International Virtual Conference. I look forward to seeing you all in our next event. Until then, stay safe. Thank you.
Thank you.
Thank you, everyone.
Thank you. Thank you. Thank you. Bye bye. Bye bye. Thank you.
Bye. Bye.
Bye. Bye bye.
Thank you.
Thank you very much.
Thank you very much.
Congratulations, Hala. Congratulations, Basil.
Thank you, Professor.
Thanks.
We are waiting you in Syria.
Inshallah. Yes, of course.
هاي فزنا هلا دكتور هلا فاز باسل جائزة مؤتمر ابو ظبي البلمان.
Congratulations, Professor Hala. Congratulations, Basil.
Much, Professor Moia. Thank you very much.
Thank you very much, Dr. Moia.
As we said, you يعني بيضتوا الوجوه